what is the probability that you are going to have your desired grade in statistics 1, which, by the way, I hope it's an A. What is the probability that 3 students will have that desired grade, assuming that the probability associated with this is the same for the 3 of them? I invite you to fill this blank yourself, okay? And then redo all the math that I have over here with your own value here of the probability of you achieving your desired grade in statistics. Obviously, this one stems from this. If whatever value you put here, this is going to be 1 minus that. Q means the probability that you don't achieve that grade. Okay, for the purpose of this explanation, I'm going to put P as 0.6. So 0.660% is the probability of you achieving the desired grade, which means that the probability that you don't get that grade is 0.4. What I'm going to study over here is all the possible outcomes for 3 students, 2 other students that have the same value of P and Q, and all the possible outcomes in terms of achieving and failing their goals in statistics 1. Okay, now it's important that you notice that you only have 2 options over here. Either you achieve your goal or you don't achieve your goal. Okay, and that the probability associated with these 3 students is the same. In this case, 0.6 for achieving and 0.4 for not achieving. Obviously, in a real world of a real classroom, different people have different expectations in relation to any subject. So this could never be done for the class as a whole. But I guess that you could take 3 people out of this class that would have the same probability of achieving the same goal, and we could work with those. Okay, so I created here a table with all possible outcomes. This first line corresponds to the situation in which the 3 students achieve their goal. This means that none of them fail. So the outcome is A, achieve, achieve, achieve. And what is the probability? It's going to be 0.6 times 0.6 times 0.6, or 0.6 cubed. This is the value. So basically, in terms of notation, this would be the probability P, okay, which is 0.6 cubed. And more on that later. Let me go just over this part over here, and then I explain this. But basically, actually, this is 0.6 cubed, and I'll talk about this combination at the end. Now, the situation in which 2 of them achieve the goal and 1 of them fails has 3 different possible arrangements. One in which, let's say that you have student A, B, and C. A and B achieve and C fail. A achieves, B fails, and C achieves. A fails and B and C achieves. All right? You have here the probability of each one of these arrangements happening, okay? But if you look at them, they are all the same. You have 2 times, you have 0.6 multiplied by itself twice, and you have 0.4 in different positions, but it's still the same calculation. That's why you have the same result. But altogether, if you add these 3 results, here you have it. This is the overall probability for this situation. 2 students achieving, 1 failing, okay? So you have what? You have 3 possible arrangements of the probability square, 0.6 square, times Q, which is 0.4, all right? 0.6 square times 0.4. And you already know that this should be equal to 3. And this equals to 1, okay? Now, only 1 of them passes and 2 fail. Again, you have 3 possible arrangements for that, okay? And here are the probabilities associated with them. Again, no matter what the line you are looking at, you have 0.4 times 0.4 times 0.6 in different positions. The probability is here. This is the overall. And now what you have 3 arrangements for probability 0.6 times 0.4 squared. Okay, how many of them? 3. Okay, and 3 combinations 1 gives 3. Combinations 3, 2 also is 3. Combinations 3, 3 is 1. And the last one is what? Is none of them achieving their goal, all of them failing. Okay, you only have one arrangement for that. That's 0.4 times 0.4 times 0.4, or 0.4 cubed. And you only have one possible arrangement for that, which is combinations 3, 0, that is 1. Obviously, if you add all possible results, it should be equal to 1. Okay? Now, this takes a lot of time, a lot of effort. It should be a simpler way of calculating these probabilities, right? And that's what I try to start organizing over here. So let X be the random variable corresponding to the number of students achieving their goals in statistics 1. So if X equals 3, that corresponds to the first situation, right? So what is the outcome? Is combinations 3, 3 of probability cubed, and I'm going to call PQ, assuming that you all know what P and Q is. P is the probability of happening, Q is the probability of not happening. So combinations 3, 3 of P cubed, Q to the power of 0. Q to the power of 0, like anything to the power of 0, is 1. I didn't bother to write it here, okay? But for the context of you trying to figure out an expression that makes sense, I'm going to put here all of them, even if it is to the power of 0. So for you, so that you can yourself figure out how this works, okay? The probability that X equals 2 students passing or achieving is combinations 3, 2, P squared Q. We saw that over there. Probability that X equals 1 is combination 3, 1, P to the power of 1, Q squared. And probability that X equals 0 is combination 3, 0, P to the power of 0, Q 3. See what is happening over here? The result, we already have it here. So we can make the probability distribution in the form of a table, which is this one over here. This is the probability distribution of the number of people achieving their goals in statistics 1 out of a random group of 3 students, again with the circumstances and the limitations that I mentioned before. They all have to have the same value of P and Q, etc. Since there are only 2 possible outcomes, achieving goals P and failing goals Q, then this is called a binomial distribution. Binomial, the term, or the bi over here means that you only have 2 different options, okay? And it is denoted by B, open brackets, and P, in which N is the number of trials, or number of people sampled, in this case 3, and P is a probability of achieving the results. So in this case, N equals 3 and P equals 0.6. So it will be denoted, the binomial distribution for this particular case, by this. What does this mean? These are the parameters of the distribution, and this means that everything that there is to know about the distribution can be taken with these 2 numbers only, right? Why? And now comes the formula that I was hoping that you would get just by looking at the information over here. The probability for X to take the value R is given by what? By combinations N, R, P to the power of R, Q to the power of N minus R, for any R between 0 and N. Look at this and compare with that. I'm going to put a random value for R over here. Let's say that R is 2, okay? R equals 2. So if I want to calculate the probability that X equals 2, then I go to the calculator and I put, what is N in this case? It is 3. 3 combinations 2. P, which is 0.6 to the power of 2, times 0.4 to the power of 3 minus 2, which is 1. I put everything in a calculator, press enter, and I have the corresponding probability. See how many parameters I need to get this value? I need to go and know the value of n, and I need to know p. If I know p, q can be calculated immediately. Immediately is just 1 over p. And the r is the thing that changes. That's why x is a variable, right? You have here a summary of what I just said. It's important to know and to stress, because you may be asked this, that the probability of success or failure is the same no matter the value of r. Okay? No matter the value of r. In the example of the students, doesn't matter how many students we are sampling. This only works if the probability is the same. Doesn't depend from student to student. Okay? Now, what is the expectation and the variance in this case? You could use the expression that you learned in lesson 1. That's all right. But the good news is that there is a shortcut when we're talking about the binomial distribution. I bothered to prove it to you over here. So I calculated the expectation, the mean, the most expected result in this particular situation. So I multiplied all the possible results for the random variable from 1 to 3 by the corresponding probability, and I got this result, 1.8. All right. So what is the expectation? What is the most likely result for the number of people achieving their goals? Is 1.8, rounded to whole numbers because you don't have 1.8 people. This would be between 1 and 2, more likely to be 2. What is a shortcut? You can get 1.8 just by doing 3 times 0.6. And what is 3? 3 is n. What is 0.6? 0.6 is p. So if you want to calculate the expectation when you're studying a binomial distribution, just multiply the two parameters, n and p, and that's it. That's the expectation. You don't have to waste time using the general expression for discrete random variables. What about the variance? Again, I use the general expression for discrete random variables to calculate the variance. So I used all possible results for the random variable squared times the probability associated with it, and I got this result, 0.72. But I can get it as well by doing 3 times 0.6 times 0.4. So n times p times q. It gives us the variance. And if this is the variance, then if we want the standard deviation, we just square root that.